When we talk about automotive coatings, it is important to move beyond the common perception of paint as a decorative layer. In OEM automotive engineering, a coating is not a single material, but a highly engineered, multi-layer protection system, designed to function as an integrated whole. Appearance is only one outcome. Corrosion resistance, durability, process robustness, and long-term field performance are equally critical objectives. An automotive coating system begins at the substrate interface with surface pretreatment. Pretreatment is not a coating in the visual sense, but it is the foundation of the entire system. Through chemical conversion layers, such as phosphates or zirconium-based treatments, the metal surface is cleaned, activated, and chemically modified to promote adhesion and corrosion resistance. Any weakness at this stage cannot be fully corrected by downstream layers, making pretreatment chemistry and process control fundamental to system performance. Above pretreatment sits the primer layer, often applied as electrocoat or primer surfacer. From a formulation perspective, primers are designed for corrosion protection, adhesion promotion, and surface leveling. Resin selection, pigment volume concentration, and solvent balance are optimized to achieve penetration into surface microstructures, uniform film build, and defect tolerance. At the process level, primer application and bake conditions determine cross-link density and adhesion to both the substrate and subsequent layers. From a performance standpoint, primers are the primary corrosion barrier and a critical contributor to stone chip resistance and long-term durability. The base coat is the most visually sensitive layer, but is still far more than color alone. Base coats are engineered to deliver color accuracy, metallic or effect orientation, and uniform appearance under tightly controlled OEM process windows. At the formulation level, resin chemistry, pigment dispersion quality, and solvent evaporation profiles are designed to control viscosity decay, wet film flow, and particle mobility. At the process level, spray parameters, flash times, airflow, and temperature directly influence metallic flake orientation, color uniformity, and defect sensitivity. Performance outcomes include color stability, face, flop balance, and resistance to mottling, striping, or patchiness. The clearcoat completes the system by providing environmental protection and surface appearance. Clearcoats are formulated to deliver gloss, distinctness of image, scratch resistance, chemical resistance, and UV durability. Solvent selection controls flow, leveling, and defect formation prior to cure, while resin and cross-linker chemistry determine long-term mechanical and optical stability. Process conditions such as film build, flash off, and bake profile directly influence gloss retention, solvent pop resistance, and long-term durability. Crucially, these layers do not function independently. Automotive coatings are approved and validated as complete systems, not as individual layers. Solvent interaction between layers affects intercoat adhesion. Rheology in one layer influences how the next layer wets, flows, and bonds. Cure schedules are optimized for the full stack, not a single film. A change in base coat solvent balance, for example, can impact clear coat flow or primer adhesion, even if the base coat itself appears acceptable in isolation. This is why OEMs approve coating systems rather than standalone products. System-level validation ensures corrosion resistance, appearance consistency, and durability across millions of vehicles under real-world conditions. For RD&I engineers, understanding these cause-effect relationships is essential. Decisions made at the formulation bench directly influence sprayability, process robustness, defect sensitivity, and long-term field performance. In summary, an automotive coating is not paint. It is a multi-layer, chemically and physically integrated protection system. Pretreatment, primer, base coat, and clear coat are engineered to work together, linking chemistry, solvent evaporation, rheology, application conditions, and curing into a single performance outcome. Mastery in automotive coatings comes from system-level thinking, not layer-by-layer optimization. If you have technical questions, unresolved coating issues, or OEM process challenges you would like discussed, share them in the comments.